We're given a series of ions to compare. We got sulfide, chloride, potassium, calcium, scandium, and they're all isoelectronic with argon. In other words, they all have the same number of electrons, the same electron configuration. And so that's very common, as we'll learn in our next chapter when we talk about chemical bonds and the octet rule. Sulfur has 16 electrons, and it's going to want to gain 2 more to have that sublevel filled, or that whole energy level filled rather. Chlorine is going to want to gain 1 electron to look like argon, and then over here on the metal side, potassium has 19 electrons. If it loses 1, it's going to have the underlying energy level full, and calcium can lose 2 to do the same, and scandium can lose 3 to do the same. So all of them are isoelectronic to each other, and that means they're going to have, in this case, 18 electrons. So let's see what that looks like. 18 electrons, if we configure them, 2 are going to go into n equals 1, 8 are going to go into n equals 2, and then 8 more are going to go into n equals 3, your 3s and your 3p's. All right, so that gives you 18 electrons. Now the difference is that sulfur has 16 protons attracting those 18 electrons. And on the other end of that range, you have scandium with 21 protons attracting those 18 electrons. So what do you think is going to have the greater attraction? So hopefully you said scandium, 3 plus cation, is going to have the stronger attraction for all of those 18. I'm not going to draw 18 arrows, but I'll draw a few of them. All right, so all those 18 electrons are going to be more closely into the nucleus. So therefore it's going to be smaller. Not doing this again. All right, on the other end, sulfide, it has 2 extra electrons, so it's just going to puff up. That's going to be the largest ion because it has only 16 protons and even more electrons, and those electrons are going to want to repel each other. And all right, second part of this question is, would you expect to see the same variation in this series? Oxide, fluoride, sodium, magnesium, aluminum, same deal, but they're all isoelectronic with neon. All right, so oxygen gains 2 electrons, fluorine gains 1 electron to become fluoride, and then sodium loses 1, and magnesium loses 2, and then aluminum loses 3, and they're all going to have 10 electrons. So it's the same reasoning. So aluminum, because they all have 10 electrons, but because aluminum has the greatest nuclear charge, it's going to be the smallest. And on the other end of that range, oxide, which is a O2 negative, gaining 2 electrons, only has 8 protons. That's going to be the largest, is what you would expect.